Welcome for this other talk of the seventh edition of the Legacy of Socrates. And we just talked about lighting documentation with Cyril, and now we're gonna see that in practice with Dr. Anna Clarkson. She's a programmer with a PhD in economics, and very interestingly, she's also the creator of a tool called Dexy, which is an open source software for software documentation, which you can reproduce. So basically, it's how you put all of that knowledge into practice with the example of Dexy. So uh, I'm really happy to have this combination of Cyril and Anna to talk about this topic because it's an important one. And Anna, I'm gonna let you explain how you do or how you're doing that with Dexy.
Awesome, thank you so much. My name is Anna. I'm recently changed my last name from Nelson to Clarkson, so if you're searching for me, you may have better luck with Nelson. And I actually didn't put the Dexy website up here, but it's dexy.it if you want to go check out Dexy. So I will talk some Dexy specifics in the second half of my talk. What I want to start out with is some of the really practical, I guess barriers is probably a good thing to call them, about automated and really deeply maintainable documentation, because it is, to me, it's sort of an obvious way to do things. And my sort of Dexy backstory is that when I was doing my PhD, I had a lot of simulation code that I was running, and then I had to get that simulation code, the results of that, into my thesis. And I very quickly realized if I didn't have some sort of automation, every single time I changed anything in my code, I would have to redo everything by hand in my thesis. So I got really excited about automation. And sadly, after I had written up my thesis, then I figured out how to write Dexy, which was designed to solve the challenges both of writing reproducible scientific research and also reproducible software documentation, because it's basically the same problem. I'm talking about writing maintainable documentation using automated tools with examples using Dexy. So one of the things when we're exploring software, we very often work interactively. So we might get a GUI interface, we might get a REPL interface, and I work a lot in Python, so I'll open up a Python REPL and I'll be typing things in there and figuring stuff out and exploring it. And that's a very intuitive way to work, and it's experimental and it's sort of exploratory. And that's how we do a lot of stuff in programming, especially when we're first exploring a new tool. We'll often work interactively at the beginning, especially. And when we're trying to write documentation, we're often wanting to write documentation about interactive exploration, because that's also what our users will do at the beginning of their work. Is they'll say, okay, let me download your tool and play around with it and see what it does and try out a few things. The problem is interactive operations are not very reproducible, because you haven't really written a clean script. You're just sort of messing around in the terminal a little bit. And this is sort of one of the issues with some automation tools. One of my favorite automation tools that's not Dexy, it's not really an automation tool, but the Jupyter Notebook, if you're familiar with that ecosystem, has it's a notebook, and it records everything that you do, and you can look at it again later. And it does allow you to reproduce work, but it doesn't sort of force you into this sort of discipline that a truly maintainable approach does. So we've got that interactive approach, but when we really want to work with reproducible documentation using automated tools, we have to be in batch mode. So that means rather than working interactively, we need to have a script that we're going to run non-interactively in batch mode, because we can run that script over and over and over again to keep generating our documentation in an automated and reproducible way. And one of the big challenges we have is that we're as the people writing the automated documentation, we're trying to work in batch mode, but we're trying to simulate interactive mode, because we're trying to coach people through an interactive use of our software, at least some of the times that we're trying to. And so what I want to say about this is that it's a lot of work up front to do this, to get in these different modes of we have to work in batch mode. We often have to simulate interactive mode. And this is a lot of work up front. For me, most of the time, it absolutely pays off and it's worth it. But I'm sort of talking a little bit today about the reality of this upfront investment we have to make to truly make our work reproducible and maintainable. So here's what I do is I start out interactively, figure out what I'm trying to show in a particular piece of documentation, then write a streamlined, clean up version of that script. So, you ignore all your false starts, all the things you tried that didn't work, and you say, oh yeah, here's the thing I wanted to work. You can work backwards and say, okay, here's how I got to this particular step. I'll just save the good parts and create that script. And then that cleaned up script is what's going to be the basis of our reproducible stack or our reproducible example, which is what we'll get to the actual sort of code for one of those in a few minutes. So I'm an economist. I studied economics. I studied computational economics. That's why I was doing a bunch of simulations. So there's a lot of helpful ideas from economics. And one of the really helpful ideas in economics is the marginal cost. And the marginal cost is the cost of producing one more or the next unit. So you can imagine here's a lovely buffet table. It's pretty easy to invite one more person to a buffet. It doesn't cost you very much. You're probably going to have food left over anyway. One more person, it really doesn't matter. So the marginal cost of inviting one more person to a buffet is very low. Whereas if you were trying to, in the olden times, go to a restaurant and you've got a table for 6, trying to get a table for 7, that's really hard because they might not have room for that, etc. So marginal cost is a very useful concept to think about. And our choices and behavior are very, very much impacted by marginal cost. That's how we make a lot of decisions in life, is this marginal cost idea. And you can really use this to your advantage by thinking about, how do I make the marginal cost of something I want to do lower? How do I make the marginal cost of something I don't want to do higher? So can you make it more convenient for yourself to do the right thing? Can you make it less convenient for yourself to do the wrong thing? And that's one of the things that really comes into play when we talk about reproducibility and maintainability. So when we're working with automation and automated documentation, one of the benefits is that the marginal cost of writing correct additional documentation is very low most of the time. And the most of the time is a big caveat, and I'm going to talk about that. If something breaks in your automation stack, and this can mean that some other library has an update which breaks your code, or you wrote a bug somewhere, or someone else wrote a bug somewhere, then suddenly your system will not let you generate documentation because something is incorrect. And this is one of the points of frustration, but it's also a really, really important positive of automated documentation, is that automated documentation does not let you write incorrect documentation. What tends to happen with manual documentation is that it's possibly correct when it was first written. Things change in the universe. As we all know, software changes and breaks all the time because some other package changes, some other operating system changes. And you don't know, if you've written your documentation manually, you don't know if it's broken. And very often the people who find out that your documentation is now broken are your users. And so with automation, it's both a frustration and it's a huge advantage that our automated systems will break when something goes wrong. And for everyone who's used continuous automation, you're very familiar with, oh no, the build is broken, we have to fix it. But when that system works, it works really, really well. And that same principle applied to documentation. That when it works, it's working wonderfully, and it's very easy to do the next thing most of the time. And that's really what we care about if we want to write additional documentation, improve our documentation, and add additional things. Manual documentation has sort of a moderate marginal cost all the time. It doesn't have this disadvantage where if something is broken in your stack, it's still just as easy to write incorrect documentation. When you're in a real hurry and under a big deadline, it can be very, very tempting to write something manually and fix it later. And we will all do this from time to time. But what you don't have, the benefit you don't have with the manual documentation is you don't get that low marginal cost after a lot of time. So which should you use? Should you use manual documentation? Should you use automated documentation? Automated documentation has a higher startup cost, especially if you're learning to use a new tool. So if you've never used a tool like Dexy before, there is a learning curve. For me, I pretty much use Dexy for every single project because for me, I'm obviously very familiar with it. It's very easy. Even if I'm sort of writing a little document or to-do list, I'll try to find a way to do it in Dexy because it's fastest for me because I have that experience with Dexy. But absolutely, there is a very steep startup cost, especially when you're using a new tool. It will take longer to get started with automated documentation. And I want to be upfront about this because I think it's important that you go into it with that awareness that it's, especially your first time, going to take longer. The investment gets repaid with correctness. So obviously you can still find ways to lie and not be super clear in your writing with automated documentation, but a whole bunch of types of errors that you don't want to make are solved by automation. So even though there's a startup cost, it's repaid with correctness, and hopefully that's something you care about. Because again, if you don't find your bugs, your users will, and that will confuse them and make your product look bad and just be a waste of everyone's time. And the marginal cost of adding new documentation is low and will eventually repay your initial investment. So in the longer term, especially if it's a larger project, this investment does get repaid, just as you're probably already familiar with continuous automation builds for compiling code and stuff like that and running tests. So there are times that shortcuts absolutely make sense, but it's very valuable. I think a lot of the time it really does make sense to make the upfront investment at a time when you have the time, do things correctly, do things in an automated and reproducible and maintainable way. So maintainable documentation is an investment with, I think, a very, very high rate of return. It's a disciplined approach, and it makes your documentation more valuable because it's more correct. It also makes your documentation very auditable. If someone has a question about something in your documentation, you have a source code behind it to back that up, to say, okay, here, look, you can look behind the scenes, you can see what's generating this. And that's great for your documentation. It means that your documentation becomes additional source material to sort of talk about what's going on sort of behind the scenes. And because it is easier to write documentation when everything is working well, it will be easier to write more and better and improve upon your documentation over time. One last thing, and this is something that I find true for me. I hope other people find it true too. I don't want to promise. When I am working with Dexy, the only thing I have to do to update my documentation is run the command DEXY on the command line. In practice, that means up arrow return, because it's probably the last thing I typed too. And because that's such a little thing, I don't have to switch brain modes. I don't have to stop writing docs and switch into, oh, wait a minute. Okay, I've got to click here and I've got to run this and I've got to do this other thing. Okay, now I'm going to try to get back into writing mode. I love the cognitive bonus of not having to switch brain modes and just being able to run a command and be going into looking at the generated version of my docs and see what I've just written rendered out and then go back to editing it. So I find it very helpful. I don't have to sort of switch out of that mode to see the built docs. My brain stays in writing mode the whole time. For me, that's great. Okay, I want to go into sort of an example. So I want to make a case that the hello world is the most important documentation for every single project. And when I say hello world, what I mean by that is basically a trivial example. So the most basic thing you can do. So maybe it's printing out what version of the software is installed. Maybe it is opening it up and printing hello, which is obviously the classic sort of hello world for a lot of programming languages. It is doing the simplest, most basic thing that can be done that demonstrates that it's installed, it's switched on, and it's functional. So why is this so important? Well, it's very often missing. So I have failed to use so many software projects because I can't get it started. I can't get it switched on. There's no hello world. It's like, well, there's a very complicated example. It left out authentication. That's a classic one. People leave out authentication and you're like, how am I supposed to authenticate? And maybe if you're really motivated, you'll go chase down 5 different things to tell you. It's very often missing. It is very often wrong. I can't believe the number of times someone said, hey, here's how you start using my software. And it's wrong. It was probably wrong, probably correct 3 versions ago. They've changed things. They haven't updated their documentation because they weren't using a maintainable automated process. Hello worlds are so often wrong if they're even there. But the hello world is very often the first and possibly often the last documentation your users will ever see. It's the first because they can't do anything with your software until they've got it running. And it might be the last if your hello world isn't helpful. I have absolutely stopped trying to use software because I just couldn't get it started and it wasn't worth my time to push farther. So I want to make a case for the hello world, but this is also just one example of the types of documentation you can automate. But it's sort of an example that touches on a lot of other things. So I want to start with that. Plus, I want to make a case for write your hello worlds. So here, let's look at, I want to look at a hello world for a library in the R ecosystem. So R is a very amazing, awesome open source statistics package, but it does a lot more than that. It's very well known in sort of data science and a lot of other fields. And so this is an example I had done a couple months ago, since there was this very cool new package out and I wanted to play around with it. So I just sort of modified this for this example. So a thing that's important in a hello world is to install absolutely everything that someone would need to get your software running. So a hello world to me truly should start at a very basic level. And this is a line from a Docker file. I'm going to assume most people are very familiar with Docker. It is a reproducible container, and Dexy and Docker play very nicely together. And I definitely encourage you to run your Dexy in a Docker container, and then you can use Dexy to incorporate parts of your Docker file to actually document your Docker file, and that can form part of your hello world. That's what's happening here. So this line of text, which is installing the R system on an Ubuntu machine, this line of text is actually coming from the Docker file that I'm using to create this environment. So a key thing in reproducible documentation, in automated documentation, is that we never have dead code in our documentation. So any line of code that you see in an example, in a tutorial, in a hello world, is coming from that code is coming from a code file that is executable and was executed in order to generate the documentation. So what we're doing is we're constructing scripts that do everything we need, and then we're using those scripts both to set up our environment, to run things, and then we're pulling, technically we're transcoding that code into our documentation. So I didn't paste this code here. I transcoded it. I told Dexy, hey, go over to this other file, get this particular line, and print whatever it is here. And if I were to change the source code and run Dexy again, it would pull the latest into here. And I'll show source in just a second. Okay, so here's to go back to the hello world example. First of all, on your Ubuntu machine, install the underlying package, then install the actual library. So this GT library is the thing that this is the hypothetical hello world for. So within R, you're going to do install packages GT, then load the library, and create a table object using the iris dataset, which is a dataset that anyone in the R world would be familiar with. And here's what it looks like. So this is the end of the hello world because we've gotten something to print out that indicates that everything is working. So this is a very simple hello world, but the key thing is that it does include all the steps you actually need to get it running. And the reason we can be confident of that is that we built it up from source code where we actually got this example running. Okay, so let's look a little bit behind the scenes. And I'm also going to say that because I'm writing these are my slides for a talk about Dexy, and I'm also trying to write a fake example. This is a little bit of meta Dexy. So this is more complicated than you should need because I'm writing a talk about a talk about a talk about. There's a lot of Dexy inception in my world, and that happens sometimes. Okay, so let's look at what's happening behind the scenes. So again, we have this very simple example. Again, for a hello world, you want a very simple example, and you should have very simple examples. Don't be afraid of them. They're very useful. But let's look at some of the complexity, but also some of the automation that's behind this. So here's the Docker file. And the relevant line in the Docker file is this one that I have highlighted here, is the apt-get install r base. And one of the tools I've used in Dexy is a tool called Auditable, which is basically lets you use code comments to divide your code into logical sections. And this is very much, Dexy is a very language agnostic, document format agnostic, and everything agnostic as much as possible framework. I have sort of a standard Dexy stack that I very much like to use, which is Jinja to create document templates. I use Auditable and pigments to provide syntax highlighting and to divide code up into sections. I'll usually use something like LaTeX or very often Markdown to write my documents. You can absolutely use anything you want. If you have other tools that you really like that help you divide code up into logical sections, or if there's a templating framework you really like, or if there's a markup framework you really like, it is almost certain that Dexy, if it doesn't already support it, can very easily support it. So I'm also showing you just sort of, in terms of the specific tools, specific formats, this is just one example, and Dexy really does support a lot of things, and I'm always happy to help you get something running if there's something you want to use it with that's not already supported, or if something's not working. So this is our complete Docker file. There's a lot more here that I need to create my Dexy environment than the users need to just get what they need running. And that's very common because we're creating a more complex environment, which is sort of our documentation stack. And we're going to use that to get our users to just do whatever small piece we're trying to get them to do in a particular piece of documentation. So we can see that at the top of this, we're specifying, what our origin Docker container is, and we're doing some utility stuff there. Here's the R specific thing. These are actually requirements for some more advanced examples, not necessarily the hello world. Often you're going to share an environment among many examples because you don't want to necessarily create it many times. So there might be parts of the script that are relevant later, say, in a different example. But in this way, we can just not refer to them in this example, refer to them in another example if they're here when we need them. Here's me installing LaTeX, so I can create this PDF. I always like to put Vim on my Docker containers because you always need it to go check out what's happening, why things aren't working. And then here's where I'm installing the particular package. So this is a separate script that's doing that second line of our demo. And finally, installing Dexy. For the R script that runs the example, so here, let me go back to remind you. So here's what we showed in our Hello World example. We said, okay, first of all, load the library, then create this, run this GT function, create a table, and print it. So This looks pretty similar to our R script because this R script is very specifically for this example, whereas the Docker file is more creating a whole big environment. So we're going to load the library. And again, we're using the same system to split our code up into sections as we saw in the Docker file. And here is the documentation source code. This is actually not quite this is not exactly what, this is the source of a standalone little article.pdf document, not the source of these slides, because this is simpler, but gives you an idea. So this is LaTeX. So this is just a textual markup language for formatting. And what we're doing is within LaTeX, we are putting in custom Jinja tags. So because LaTeX makes generous use of curly braces, we just use angle braces as customized Jinja tags. Normally in an HTML document, curly braces are great and very unique within that environment, so we don't need to use that, but this is a custom setting. Another thing that Dexy does is it makes it very easy to store custom configuration for different commands that you call. So it's very easy to say, hey, I would like Jinja tags to be this for this particular document. You can specify and customize things. So what we're doing here is we're identifying the snippet of text that we want to pull in from an external file. And we're identifying the document, we're identifying what filters that document is passed through before we use it. And then we can identify a particular section within that document and include it here. And so we can see that this first line comes from a script called install.r. And these last two lines come from a script called gthello.r and from these two different sections. And then finally, we're incorporating an example file that is that generated table that was the goal of all this. And here is how we tell Dexy what we want to do. So Dexy, some of the basic concepts in Dexy, and there are tutorials and explainers for Dexy, so I'm not trying to sort of do an intro to Dexy. I'm trying to give sort of a high-level conversation about the ways in which it's used and how it contributes to maintainability. So what's happening here is that we're specifying the documents we'd like to be processed. And in this case, we want our slides, which are written in LaTeX, to be processed through two filters. And so a filter is something that changes a document. A filter can do anything. It can do something like change a PNG into a JPEG, and it can also it can execute code. It can apply syntax highlighting. And in this case, what we're doing is we're first of all applying the Jinja filter, which is saying, okay, treat this document like a template and go find all the Jinja tags and fill in the information that is being requested. And Jinja, there's a whole class of templating stuff within Dexy, and it knows that everything that's listed here as a dependency, so everything indented under here is a dependency, all of these dependent files with whatever processing they've had are made available to the templating engine. So Jinja, we're going to look for our little Jinja tags, and it's going to say, first of all, okay, go find me the install.r file that was run through these filters. And here's where we specify that any R file should be run through those filters. And then pull out that particular section and stick it in this point in the document. So the first filter fills in all the blanks, and then the second filter says, okay, now I have a LaTeX document. Let's make a PDF out of that LaTeX document by running the LaTeX compiler. And so you can have as many, this configuration file can be as complex as you'd like it to be. It can have all sorts of nested dependencies. And a really important feature of Dexy is that Dexy will cache everything that hasn't been changed. So one of the things I talked about, that sort of cognitive feedback loop earlier on, and the importance of not having to wait too long to get out of a certain mode. So Dexy's caching is really important, because if you are just changing your slides a little bit, you don't want to go rerun all your simulations, right? Because those haven't changed. All you've done is change your your lecture notes or your book draft or your blog post draft. So what's the caching works by, there's a huge dependency tree. So if any of these elements were to change, it would regenerate your LaTeX file because that's referring to them, or they're listed as dependencies. However, if just your top level file where you're writing what's going on changes, it doesn't need to redo everything else. So it's very efficient that way. You can just work on your slides that way. Okay, so that is a kind of very quick, high level discussion about Dexy, and I would love to sort of hear some questions, and also if anyone has a, hey, how might I use Dexy in this situation? I'd love to hear that too.
Thank you very much. That's really interesting, and I guess Dexy. So here you are showing an example with LaTeX, but as you mentioned, it can be used in many different formats, right? Yeah.
So I do plenty in HTML because that's obviously very handy for doing. You can do static site generation in Dexy. One of the early things that was made me very happy was publishing blog posts, connecting directly, for example, to the WordPress API, and not having to deal with copy pasting code into a GUI text editor that was going to mangle all your markup. So yeah, absolutely. Working with, I'll often use Markdown, convert it to HTML, and then either paste that somewhere, or if you want to do blogging or something like that, or even tweeting, social media, you can connect directly to an API and push your HTML, or even something like Jira, something like that.
Yeah, that's impressive. As you said, there is certainly a startup cost, but the documentation on the Dexy website has a getting started and how to get everything running. Your Hello World example, basically, that people can follow, so then they could imagine more usage. And Cyril, so that's interesting because I noted that Cyril was using annotations, but is mostly also working with Java. And you're using custom comments, right? So you have your own conventions.
Yeah. So that's so one thing I really like to clarify. Well, I think Kathy Sierra was the person who wrote about this, that I found this. And it's, I think, more widely acknowledged now, but there's such a difference between tutorial documentation and reference documentation, right? And so reference documentation is when, like, you want a dictionary, or you want to be able to go look up every single function in a given package or library. And so if you're writing a tutorial or a how-to or a cookbook example, that's not really reference documentation, and you want to write a script and guide people through step by step. And that's what that idiopathic syntax is great for, is saying, here's my script. I want to break it into sections, into nice little pieces, and go through step by step. If what you want to do is write reference documentation, or if your file already has a natural structure, like it's organized into functions, for example, I would use a different tool. I would sort of use a language parsing tool to just take advantage of the structure that's already there. So I have that for Python and Dexy, and it can certainly be added for other languages, where you just, by virtue of writing a class and writing functions in that class, we use a parser for that language, and it just pulls out that structure and exposes it to Jinja, and you don't need to add any special comments because you've already got a structure there. And then you can use that either to write reference documentation, where you just say, hey, go through the list, pull out every single function in this class, and print docs for all of them, which is what a lot of automated, dedicated tools within a language do. Or you can still use that for sort of tutorial documentation by pulling in one function at a time as you make use of it. So you might have a script, and you might go through and sort of show your script, and then say, hey, here's the function we're calling, here's the reference for the function, and it'll go pull that from that other document where you've got that, which is helpful. So yeah, it's sort of giving you the creativity and the freedom to say, okay, what type of documentation am I writing here? Should it be based on a script? Should it be based on library methods? Should it be a little of both, and pulling those together from those different sources?
Yeah, it's very versatile. We have a few questions popping in the chat, so I'm gonna start with the first one. So tied with the previous DevOps and live documentation talks, question is, does Dexy work well in a CI/CD pipeline?
Yes. Yes is the answer, because it's a command line tool. It's designed to be non-interactive. It has things like, it'll exit with 0 if it's successful. But that would be a great use for it, is to build it in there, and yeah, it would be very well suited for that.
Yeah, totally automated. And by the example you presented, and yeah, it seems to be very nice with Docker and things like that. So you can totally integrate that.
Yeah, you can just have it be something else in your Docker environment, and then build. And the really nice thing there is that when your docs break, your build breaks and you know about it, right? And obviously,
yeah,
but it's better than not knowing that your docs are wrong or broken. So yeah.
That's true, because the faster you know it, the easier it is to fix it, rather than realizing it like 1 week later and now you don't really know what
right,
broke.
10 things have changed. Then yeah,
exactly. All right, so next question. Can Dexy use diagrams to make it easy to verify the solution architecture? So I guess it's like generate diagrams of the architecture from the code.
Yeah, so I think there's a couple different ways I could take that question, but I'll try to get to what I hope is the answer. And if I don't, then ask again or email me later. So first of all, Dexy can use any document format, and the document format, if that supports graphics, then great. And so HTML, obviously, you just include a graphic. LaTeX, you can include graphics. I think, though, what's being asked is sort of automatically generating diagrams about your code and including those. And as long as there's a command line interface to whatever it is that's introspecting on your code, the answer should be yes to that. And what I do in my sort of stack is I'll often, a lot of those tools generate dot files that go into GraphViz. And so that's a very well supported feature in Dexy. So if you've got some command, some tool that will generate a dot file, then you just take that dot file, run it through a GraphViz filter, get whatever type of image you want out of that, and incorporate that in your document. So that, and if there's another tool there, as long as it has a command line callable interface, then it should be no problem to integrate that as well.
That's perfect. And yes, the moment you got a dot file, usually it's compatible with most visualization solution out there, GraphViz being the most popular and standard one. Okay, next question is, does it integrate with Stack Overflow? So for example, it would be nice to have an example on GitHub that is then placed in a question and updated when more info on an issue are discovered, for example, like a live synchronization.
Yeah, so I would need to look into so Dexy generally runs sort of statically, right? So first of all, I think Stack Overflow has an API for publishing questions and answers. I believe
I guess there is one. I never used it, but I guess
okay.
I wouldn't be surprised.
So I would say I may have played around. So again, hopefully I will actually answer the question, and if not, let me know. But if there's an API, Dexy can publish content to it. So it might take writing a custom filter, but that part is straightforward. In terms of getting stuff from GitHub and pushing to Stack Overflow or something else and having that automatically update, I will just say that Dexy runs statically, right? So Dexy runs when you tell it to run. It might run as part of, as someone mentioned earlier, a continuous integration process. You might trigger it to run based on a cron job or something like that. It's not going to, you could also have it watch certain files and automatically run if the files change. Apart from that, it's not going to automatically push anything anywhere, right? It's a static content generation tool that only runs when it is told to run. But it certainly, in terms of creating, if you want to format your question and pull a bunch of code into your question and push that to Stack Overflow, and if then later on you want to update that and push it again to Stack Overflow, again, assuming they have an API, that should be fine. And if they didn't have an API, you could just generate the HTML and paste that HTML there pretty easily and do it that way. So I think, yes, if I missed something in the question, feel free to drop me an email about it.
No, I think you answered it quite well, and it's very flexible. It seems very flexible. So basically, a lot of cases you would imagine you can do it. But yeah, as you said, you would need to build up a server to subscribe to the GitHub API to be notified and then to execute the code. But everything can be run programmatically, so
Right.
nothing is blocking you from doing so. All right, that's it for the questions. We're gonna take a break, and thank you very much again. That was really interesting. And
my pleasure. And thanks for having me. And here's my email again. So if anyone has questions about Dexy or wants to sort of run through some use cases or ideas, feel free to drop me an email.
That's perfect. All right. Well, let's take a 20-minute break, and we'll see you for the last talk on hexagonal architecture. Thank you again, Anna. That was amazing.